Now let's move on to the third part of our analysis, which is looking at the patterns of inactivity across different criteria, be it age groups, city tiers, subscription plans, and so on. So yes, we are going to look into that. But for this, we have to look into this, I think, last active date, most probably. Let me just have a look again. Inactivity analysis. Okay, so we will definitely need to have the last active date. Okay, now how should we begin? What was the name? Okay, let's see what we can do here. Let me print this again instead of scrolling up over and over again. Let me print this thing again. Let's combine subscriber df per head. Yeah, I have to run it again. I forgot. Once while this runs, let us think about how to approach it next. How to approach this problem. But before that, we'll also have to, like we have mentioned here, that it has quite a lot of null values. So the question is whether it's even worth exploring if there are so many null values in a single column. So yes, if we look at the column last active date, so out of 2000 rows, 1426 of them are rows with null values. So almost 3/4 of them are null values. So, but let's still see what. But let's still see if we can do anything about this. Because it has null values, we will have to get rid of this. Okay, we'll look into that, but right now let's just continue with it. Okay, so first of all, what I'll do is try to convert the dates into date time format, and then let's see, I'll use this code, and yes, now it's being converted. So what's going to be our definition for inactive users? So we will consider that if a user has not used it for 90 days, we will consider that user to be an inactive user. So what's the formula for that? For that, suppose, so we know that the data, as I think so it's being mentioned here, The data is from January to November of 2024, and so we will assume that we are doing the analysis on the final day of November 2024. So if someone is inactive for 90 days, by taking into reference 30th of November as the current date, the date that in which we are doing the analysis. So if someone hasn't been using for at least 3 months or more than 3 months as of 30th of November 2024, we will consider this user to be an inactive user. So I hope you got the logic, and yeah, so that's what we're going to implement here. Okay, so that's why we have assumed the current date to be 30th of November 2024. Now we will create a new column here in this data frame, which we will call it as let's call it last. Okay, so is it inactive? Is inactive. Let's call it is inactive. Okay, and we will divide this. Okay, we will subtract. Okay, we have to calculate this thing, so we will subtract the current date with this last active date of that row. Okay, what else? Yeah, if it's greater than 90, it will be there. There's a spelling mistake here, it should be date. Okay, if it's 90, let's try to run this and see if it works or not. This is probably because yeah, we have to convert this to time.delta time because it's an integer and we can't compare a date time value with an integer value. Both of them have to be of same data type. Time delta this equals, I hope it works. Yeah, there's this spelling mistake and should, oh no, time delta isn't working. Let me see what's the problem here. Yeah, the reason it's not working because we have not imported this. So from date time we have to import two things. Let us import date time and time delta. Let's see, there we go, it's working. Now let's print this again. Let's print ahead and see what updates do we have here. Look at this, we can see whether it's active or inactive. Okay, Also, let me tell you another thing which I have assumed here is that wherever there is NAT in this row, in that case I assume that they are active as of 30th of November. That means they use it regularly. Hence, there is no last active date because they use it regularly. So, any row where there is a NAT value, that means the the user uses it regularly. Hence, there is no last active date. So, I'm working with that assumption, and hence because of that reason, we have is inactive as false here. Okay. But let's, for the sake of curiosity, let's look at it. How many of them are true? Oh, okay. Dot. So they are both false and true. So there exist certain things, certain values. Forgot the exact formula. Is it this? No, that's not it. But anyways, let's continue. We got the idea about what it is. It has both true and false. Now what else can we do here? Let's look at inactive rate. Okay, let's look at inactivity rate by platform. Okay. So we will group by platform and see how many inactive users are there for each platform. That's something we can do. So let's call it as inactivity rate. And here, let's look at it. Okay. Since we are calculating rate, let's also multiply it by 100 so that we get it in percentage. Let's try to print this thing and see what we get here. For Jotstar, it's 6.5%, and for Leo Cinema, 16.1%. So, so it's actually good news because most of the users are regular users. The inactivity rate overall is quite low, and Jotstar's is even more low. Okay. Let's look at inactivity rate by age group. That's okay. Let's try this. So we'll group both by platform and age group here. Let's see. We will have to unstack it and see if it happens. No, no, it doesn't work. I haven't. It's a silly mistake, but you have to be careful about this. There we have. There we go. Now let's try to print this thing and see how accurate this is. Okay. But this doesn't, just pure numbers doesn't give us much insights into it. I mean, it's quite difficult to interpret these numbers. Let's see if you can plot this. That give us a better perspective on these numbers. Okay. Okay. So agent activity dot plot. What kind of plot do you want? Let's go with bar plot. Okay. And access. With this, let's just exclude this for the moment. Let's yeah. Okay, before that we have to define the graph with figure and axis. Okay, axes are fine, but I haven't even asked it. Let's run and see. Okay, yeah, we don't need subplots. So what's wrong here? Just a minute, let me look at the syntax above, the way I did it. Yielded figure, okay. Let's copy this syntax. Get all of this. Here we have it. So the interpretation here is that of all the inactive users, so in total for JotStar we have 6.5% of all the users are inactive. Of those 6.5%, if we further divide it in terms of their age groups, we can see that, okay, how do we interpret this? Is it 7.5% or 0.075%? Multiply this by 100 and maybe then we might get some idea behind this. Yeah, but now it doesn't make sense because it's 6% here. Okay, I need to take a look at this thing. So all right, I got this. I understood uh, the confusion that I had here. So initially I thought that, okay, so for JotStar, if the percentage of people that are inactive is 6.5%, then this should add up to 6.5%. But my logic was flawed. That's because this 8.5% means that of all the subscribers that fall into the 18 to 24 age group, 8.5% of all the subscribers are, yes, they are inactive. Similarly, for all these, out of all the subscribers in the age group of 25 to 34, 7.72 percentage of them are inactive. So this would follow that the average of all these four should add up should come out to 6.5. I think that's the logic here. So let me just try to do this. Okay. Let's try to add and try to find the average of this thing. 8.58 plus 7.72 plus 3.95 plus 4.5, and then if we divide it by 4, then let's print x. Let's see what's the answer. Yeah, it's pretty close to 6.5. Because I have rounded off these numbers, so there is a bit of discrepancy here, but otherwise it's very close to 6.5. So that's the logic here. It gives the percentage of people that are inactive in each particular group, not as a whole. So yeah, I hope it makes sense. Now, what did we do? We did it in terms of age. Now we can do similar, but in terms of city tier. So the rest of the code will be same, except we will be doing it for, did I just cut it? Okay, let me, yeah, I I have to rewrite this code again, and yeah, that's a bit of a headache, but let me do this again. What was it? What did I name it as? Age inactivity. Activity equals, what was the data frame's name? Combined subscribers TF. Group by platform and each group. The column active 200. What did I do? Stack it and then plot it. Yeah, so if you unstack it, we plot it for each streaming platform separately. Now let me copy this one. I'm careful this time, and instead of age group, let's do it for city tier. And let's replace it with city inactivity. Let us also print it and see what is the kind of results that you get here. Okay, okay, so let's plot this thing again. So instead of age, we are going to replace it with city, and we'll get a similar. So again, it gives us a similar kind of result where for JotStar, if you want the exact number, for JotStar, 4.6% of all their subscribers from tier 1 are inactive, and 9.2% of all their subscribers from tier 2 cities are inactive, and so on. So if you look at this comparatively, most of Leo Cinema's subscribers are inactive as compared to JotStar. Okay, we got somewhere. Now we can do the same thing in terms of subscription plan. So again, Control C, and most of the code is same, just we have to replace it with subscription plan. Let me replace this with plan, and this with plan 2. If you run this, we get something. Yeah, so we're getting a NaN value because for JotStar there is no category as basic, and for Leo Cinema there is no VIP category. So that makes sense. Apart from that, everything is fine. Okay, and let's plot this. There we go. You can see inactivity in terms of subscription plan. So yeah. Now one more thing that we can do is we can look at the inactivity trend over time. That's something you can do. So I'm just going to copy and paste this code, and let's see what happens. I'll fix a little bit of the indentation here. Combine, what's the name again? Subscribers df. Subscribers underscore df. Okay, what does that even mean? For me, it's very hard to interpret what we are looking at here. It's either 100 or 0, and there's no data for Jotstar. So yeah, it's quite difficult for me to understand what's happening here. So let's leave this out. Okay, I am not able to understand what's happening here, so let me just leave this one out. So in terms of inactivity analysis, these 4 graphs are enough for now. Actually, we haven't drawn a graph for this one, did we? No. Let's look at it and see if we can draw some kind of graph for this one as well. Actually, we don't need much of a graph here because most of the necessary details are here itself. Here we only have 2 numbers, 6.5 and 16.1. That's pretty much self-explanatory. Nothing much to illustrate here. But for this, these graphs work very well to illustrate the idea. So let's get back to this document here and see. So yeah, we're done with the inactivity analysis. So 3 more categories left: upgrade patterns, downgrade patterns, and content consumption behavior. So yeah, next we'll start with the step 4, upgrade and upgrade patterns, and if possible we'll try to do both together, upgrade and downgrade patterns.